Greetings and welcome, friends. Mr. Waddy here and my fellow geometricians. We are talking about trigonometric ratios, which are wonderful when it comes to solving right triangles. Actually, solving right triangles tomorrow. You don't technically know how to find angle measures just yet, just side lengths. So today I'm going to give you a right triangle and one of its acute angles, and then we'll be able to find any other sides once we know one of them. So far we are familiar with the tangent ratio, which you could call TOA. Tangent was the ratio of the opposite to adjacent. And today we're learning two more, sine and cosine, which will be abbreviated as sin or cos. Now, we still technically will mention, call that sine and cosine, even though it looks like sin and cos, but that's okay. So anyways, sine is from, let's look at angle A's perspective. Sine is the ratio of the opposite leg to the hypotenuse. That's it. Opposite to hypotenuse. And cosine will be the ratio of the adjacent to the hypotenuse. One of the ways that you might remember this is with the acronym SOHCAHTOA. Yeah, so sine, cosine, tangent. So let's see, adjacent. I've got opposite there and opposite there. And then I've got this new feller, the hypotenuse. Well, what these are is the sine of an angle gives you a ratio of any triangle's opposite leg to hypotenuse when that's the angle measure. It'll make more sense once we start putting it to use here. Let's see, as my screen dims ominously as example 1 enters the room. Here we go. Example 1. All right, let's find sine S, sine R, cos S, and cos R. Here we go. So if I want to find sine, actually this is a lowercase s, by the way. Capital S sine is technically different. Sine of S, let's look at where angle S is, right here. From S's perspective, the opposite is 63, the opposite leg, right? And the hypotenuse is the 65, and the adjacent is the 16. So the sine of angle S is just opposite over hypotenuse. Done. The cosine from angle S's perspective would be the adjacent to hypotenuse ratio. So 16 to 65. Right? And while we're looking from angle S's perspective, what would the tangent of S be, even though this problem didn't care to ask? Opposite to adjacent, excellent, would be 63 over 16. They did also ask for 4-digit decimal approximations. We might as well produce those, or I could have just cheated. I'm just going to cheat. Hey, I have it right here. 0.9692. This one is going to be 0.2462. And the tangent, since I had it here, I'll give it to you, was 3.9375. Now, as far as sine and cosine, notice that tangent actually has the ability of being larger than 1, but sine and cosine will never be larger than 1. Could someone explain why they think that might be true? Yeah. All right, student Waddy fan 17 said that that for sine and cosine it's always divided by the hypotenuse, and so the other side lengths of those legs are going to be smaller, and dividing by a number that's bigger is going to always be less than 1. This is what they said, word for word, verbatim, I think. No. So cosine, or let's do sine. Sine of R The only thing that's going to change is what the opposite and adjacent were. So from R's perspective, we'll do it this way. The opposite now would be the 16, and the adjacent would have been, right, the 63. So this is going to be 16/65. The cosine of R will be the 63/65. Interesting. And I bet you guys could calculate these without even touching a calculator right now. Yeah, wow. My student just like knew that value right off the top of their head. That was amazing. Ooh, yeah. Yeah. So maybe you noticed this and this. Does that make sense? That those would be the same? Yeah, because sine of S was opposite over hypotenuse. Cosine of R is adjacent to hypotenuse. And they were talking about the same thing from different perspectives. Eventually, yeah, that's tomorrow's task. Let's see, if I wanted to figure out Danny Tanner right there, what would tangent of R have been? From R's perspective? Yeah, my colors are all discombobulated now. So 16/63. That I can't find here unless you know how to reciprocate 1, do 1 divided by 3.93. It's about 0.2540. No, was it 39? I'm gonna say 40. 40. Yeah, I had to round on that one a little earlier. So that's kind of cool. So far, you still don't necessarily know what we're doing. You found these things, but it's like, what do I do with these ratios? We also noticed another relationship, which is that sine and cosine of complementary angles are equal to each other, right? So sine of one angle is going to be the cosine of another angle if those angles are complementary. How did I know that these two green angles were complementary to each other? Yeah, 180 minus 90 is 90, so yeah, it's like a corollary of the trisum theorem, something like that. Yes, so it turns out that the sine of angle A is going to equal the cosine of 90 minus A. Right? That if I find the complement of angle A, that's going to be the same in that case. And then they rewrite that a whole bunch of different ways, but we're fine. All right, we'll do one of these. Here we go. Example 2. Write sine of 56 in terms of cosine. So that's going to be the cosine of 90 minus 56, which is the cosine of 34 degrees, I believe. And then I'm done? Do you believe it? Actually, you could plug both of those in a calculadora if you wanted to. Right? Just for funsies. But I'm a little bit more interested in getting into the real value of sine and cosine here. Ooh, am I going to have to run my document camera today in order to show you how to plug this in a calculator? I don't know. My hands are so old from when I started this Waddy Math channel. Oh dear. I'm like... Yes. Based on these. Here, look at it here. It was sine of one angle was the same as cosine of another angle when those two angles happened to add up to 90 degrees. Well, here, watch this. Ooh. Oh man, I'm playing this at way too high a resolution here. Oh, it's super blurry. My frame rate's terrible. It's not blurry. It's bad frame rate. So sine of 56. If I do sine of 56, and I'm going to live like a rebel, I'm not closing that open parenthesis, I get 0.8290. And if I do cosine of 34, the same value, because those two angles are complementary to each other. So let's take a look at this one. Find the values of x and y. This is where this is helpful. Let's put this to work. Why would tangent not have worked for me in this problem? Correct. Student said we don't know the opposite or the adjacent. Yeah, that's correct. That's correct. But I do know the hypotenuse, and I can compare either opposite or adjacent to that hypotenuse using sine or cosine. So let's say I wanted to find x and compare it to 14. What trig ratio would compare x and 14? Sine, because that's the opposite and the hypotenuse. Technically, I preemptively thought that the x was going to be in the numerator. In this case, I was right. So I'm going to say that sine of 26 degrees is equal to the opposite to the hypotenuse. What is the cosine of 26 degrees going to equal? What? Oh, no, I'm not even worried about that. Like, I realize that is what we talked about a moment ago here. But I'm more thinking cosine is just the adjacent to hypotenuse route. I do like how colorful that is. Ooh. Yeah, y over 14. And once I set up those ratios, I can now solve these equations. I just punched my camera. Man. Fortunately, it wasn't looking at me when I did it, because then that would have been a viral video. My camera aggression. So multiply both sides by 14. You have no proof, camera. X equals 14 times 26 degrees. So x is about, and this is where I can plug that in, 14 times sine of 26, and I'm in deg mode right there, notice. And I get 6.1372. And technically, I didn't need cosine after this, did I? And also, they told me to round to the nearest tenth, but you know what? I don't care. I'm a rebel. Once I know this, I actually didn't need the cosine setup. What was another way I could have found y? Yeah, just Pythagorean theorem, y squared plus this squared equals that squared. That also would have worked, but we'll use cosine because we're trying to get used to something new. I would multiply both sides by 14. You guys see where this is going. So y is equal to 14 times the cos of 26. Y is approximately, let's see, can I edit this old one? Use some arrow keys here. Notice there's the old cosine. And 12.5831. Whoa, that was weird. 12.5831. So, and it's not a bad idea to just like verify using triangle inequalities that like your longest side is opposite your largest angle, your smallest side is opposite your smallest angle, and your mediumest side is opposite your mediumest angle. Right? It's a good idea to do that. Let's see. Let's have, how are we doing for time? We're good for time. I'm going to have you guys try this monitoring progress question 3 right there. Internet friends, you can just hang out, and until you see this mouse start moving again, you can just watch after that. Just scrub through the video, but who knows, maybe you're missing some amazing, like, singing by yours truly. Oh, like some cool intermission stuff? here. I bet it uses sine and cosine. Oh, you guys figured out how to use your sine and cosine. Weird backwards. All right, I'm just going to start doodling here. You guys keep working. Man, my throat's making crazy sounds after drinking that water, though. It's all going... Does anyone know what I'm talking about? How that happened? No? Is that a thing? Does that happen to other people? That's weird. I wish I could have recorded it. I stole that from the book's answer here. Let's see. And if I wanted to find u, u is the adjacent. 8 is the hypotenuse. Cosine, right, compares the adjacent and hypotenuse. Right, so I'm picking the trig ratio based on what things I'm comparing. So I would say cosine of 65 degrees is equal to u over 8. U would equal 8 times the cos 65. And u are approximately 3.4. Yeah? You guys get how we do that setup? Ooh, example 4 is not going to be that interesting. I mean, just wait till you see this. This is amazing. It's the coolest thing on the internet. Let's draw a picture or something. Imagine I had... Nope. Ish. 45, 45, 90. Triangle. The ratios of those are that, and this is those. So if I wanted to find the sine of... Let's look at this angle's perspective. I would compare the opposite to the hypotenuse. So sine of 45 degrees, you'll have this memorized one day, is 1 over the square root of 2. Of course, I can't leave the rad 2 in the denominator, so I've got to multiply by rad 2 over rad 2. Yeah? So sine is going to equal rad 2 over 2 for sine of 45 degrees. And guess what? Cosine's the same. What? because those are complementary angles, and we had that property a moment ago. Let's see. I'm going to skip example 5. You guys can figure it out. Let's talk about real-life problems like depression. No. Oh, am I? No, I'm recording this. But no, solving real-life problems. Depression. Here we go. So imagine you're like, I don't know, like a cool airplane or something. Alright.
Wait, why is the trail coming from?
No, this is where it's looking. But you're right, okay. Alright, here's my cool airplane. It says the angle that a downward line of sight makes with a horizontal is called the angle of depression. So let's say this airplane is looking at, I don't know, an amazing house that was hyper-realistic. Like so. The angle of depression would be this angle right there, right? So that's the angle of depression versus an angle of elevation is if you're looking up at something. Depression is when you're always looking down on life. Let's talk about skiing here. Skiing's a weird word because it has 2 eyes next to itself. Skiing, double I. I imagine the word radii is also like that. Oh yeah, this is not proportionate. That's a giant right there. If this is 1,200 feet, that person's like 400 feet-ish, maybe? I don't know. So you're skiing. You know that this opposite is like 1,200 feet. You're looking for that sweet slope, that hypotenuse right there. There it is. What trig ratio compares that and that? That looks like sine to me, because sine of 21 is going to be the opposite over the hypotenuse. Uh-oh. My variable's in the denominator this time. So you can multiply both sides by x. Something like. So x times sine of 21 is equal to 1,200. Remember, sine 21, it's just some number. It's a decimal, right? So divide both sides by sine of 21. And we should get something. It's approximately 3348.5. And that looks like feet to me. So that's the length of the slope there. If you descend 1,200 feet at a 21-degree angle of depression, that's what it would be. Well, anyways, thanks for watching, internet friends. Bye-bye.